Make sure you understand this is going to be the formula sheet section they give to you for circular measure. It's on here. As in, they give to you two formulas that are involved in these types of questions for circular measure, for these types of, compound shapes where you have more than one shape combined together to make overall an area you need to find or perimeter you need to find. They give you formulas in the formula sheet over there, MF19, first page, for the arc length of a circle and the area of a sector of a circle. Those are two formulas we're looking at right now. So make sure you understand the arc length of a circle. It just means if you have a circle like this, arc is just talking about. So look at the circle from the bigger one, the ABD one. This is just going to be the arc length like that. This is the arc length of a circle. This is the arc length of a circle. Okay, arc length is just talking about a certain portion of the circumference. As in, it's just the distance. It's measured in length. It's the length of a particular section of the circle. So you wanted this point to this point, however long that is. That's an example of an arc length. Okay? If you wanted, say, the distance from B to D, this curve, like this whole thing measured. Imagine if you took a measuring tape and wrapped it around the circle from B to D, that sort of curved distance over there, that is going to be another example of an arc length. And what you need to know about in the formula sheet is the arc length of a circle is just always going to be calculated. This is an instruction over here. If you want to calculate a particular arc length, let's just say if we want to calculate the distance from B to D, that's an arc length. Yes or no? Do you recognize B to D as an arc length? B to D like this is an arc length. So if you want to find the distance of an arc length over here, you would use this instruction, which is going to be the radius multiplied by the angle it makes. What's the radius of the circle over here? 10, and it's going to be multiplied with, because you identify r theta just means r times theta like that. So you already have the radius over here, which is 10. You must multiply it by the angle over here in radians. So principle over here you got to realize is the angle over here, if this is 1.2 radians, this angle over here is going to be, this might be a little bit confusing if you don't understand the concept of radians, but just think about it this way, okay? This is a full circle. A full circle has 360 degrees. If you took 360 degrees minus whatever this angle is, you're going to be left with this angle. And what's the instruction say for the arc length of a circle? Remember, let's tie this back together. Make sure you understand we're trying to find the arc length of a circle like this. If this is an example, we had to find the arc length. This applies, this instruction, and this instruction is just going to be the radius, in this case which is 10, multiplied by the angle of the sort of curve we're looking at. See how this is the angle? This is the angle that represents the arc length over here. It's this angle, which we would find by doing 360 degrees minus whatever this angle is. We're not dealing with degrees, but we're dealing with radians, so make sure you understand how this angle over here is going to be given by 2 pi minus 1.2. Okay? Because 2 pi, this basics over here, 2 pi represents 2 pi's radians, 1 pi represents 180 degrees, so 2 pi is going to be 360 degrees. And you see how 360 degrees minus this angle, by default, is going to give you this angle over here, which is what we want to find. This is the theta over here. So without further ado, we understand that the arc length in this context is just going to be distance from B to D is equal to arc BD is equal to 2 pi minus 1.2, which is the angle, multiplied by, we put brackets, brackets means multiply, we'll multiply that by 10. Whatever this number calculated, if you input in your calculator, this is going to be the number that represents the distance from B to D curve. Okay? Just like if we wanted to find this curve distance over here. If we completed the circle, notice how the big circle over here is incomplete. They just chucked like another half circle over there over it. If you want to find this particular distance, this curve from B to D, the smaller one, see this? Is this an example of an arc length, yes or no? Yes or no? Is B to D an arc length? Yes. If it's an arc length, we follow this instruction for arc length, which is r theta, which is going to be 10 times whatever this angle is over here. We always multiply by the angle that makes up this portion of the curve of the circle, which is going to be 1.2. Because this angle is already given to us in radians, right? In radians. Area of the sector of a circle. The area of a sector of a circle is just going to be this whole thing over here. For example, if we want to find this, do we identify this as the sector? If that's not so obvious, think about an easier one. If we want to find this over here, that's an example of finding the sector of a circle. If we wanted to find what's the area of the circle over here like that, or if we want to find the area of the circle like this, or if we wanted to find the area of the circle like this. Do you see how that's an example of the sector area? Area of a sector of a circle? Area of a sector of a circle, just like that. And it's just following this instruction over here. So let's just say hypothetically if this were 30 degrees, area of the sector would be found by doing a half times radius squared, which is 10 squared, times it by the angle over here. The angle we can't just do 30 because it needs to be angle in radians, so we do 30 times it by pi over 180. Degrees to radians is always multiplied by pi over 180, and that's where we get 1 over 6 pi. Whatever that is on your calculator is going to be the area of the sector over here. So do you see what a sector is? A sector is just a slice of a circle. A perfect circle, pie graph, imagine that a certain slice of that portion of it is going to be what a sector is. So if we wanted to find this particular sector area like that, it's just going to be follow this instruction. 1/2 times 10 squared times 1.2, just like that. Okay? Another example, if we want to find this particular distance over here, is that an arc length or is that the area of a sector? It would be arc length, wouldn't it? So the arc length from A to B, so we can say AB, is just going to be, follow this instruction, radius times angle. Radius is 2r, so it's just 2r multiplied by whatever this angle is over here in radians, which indeed it is already in radians, so which is 1/6 pi. Whatever this on your calculator is, it's just going to be a third pi r like that, right? That's going to be something that represents this arc length, A to B. If we wanted to find this overall area, we would just do what? Identify it's going to be the area of a sector scenario, which is just 1/2 times 2r squared, times that by the angle over here, which is 1/6 pi. Whatever that simplified is, that's going to represent this full sector area. If we wanted to find this particular distance over here, right, that's an example of an arc length, isn't it? It just means what we had to find whatever this angle is. And that's what they mean by theta over here. This is going to be theta multiplied by 5. So 5 theta is what represents this distance over here, C to D. Area of the sector of a circle, same thing over here. If we want to find this area, it would just be what? You identify as the area of the sector scenario, which is going to be 1/2 times 5 squared times this by this angle over here. Just like that. Just like if you wanted to find this area over here, which is going to be 1/2 times 8 squared theta r squared, 1/2 times r squared, yes, if you want to find this. So 1/2 times 8 squared, because 8 is radius, multiply that by whatever this angle is over here, in radians. So what even is the point here? Why do we care? We care because when you're doing exam questions that are usually worth a lot of marks, when there's multiple steps involved, because you can tell for an 8-mark question over here. So this is an example of an exam question, 8 marks. There's usually going to be a lot of steps involved. They involve a lot of the basic formulas that they don't tell you about. You have to recognize when to use them. Example over here, if you want to find the area of the shaded section over here, which is what they're asking, you'd realize at any given point, of course you need to find this particular sector area, don't you? ABC. You need to find this particular area from OCD. Do you see why we care about those formulas? We need to know how to calculate sectors when it makes sense to calculate sectors. When we see a scenario where it makes sense to calculate the area of a sector, then we better know how to calculate the area of a sector, is my point. So look how this is used for this example over here. If you want to find the area of the shaded region, it would have involved taking the area of the triangle minus these two sectors over here. And you see why we've articulated that over here, right? Finding the area of COD, which would be, on the formula sheet, if you needed it, the area is just going to be 1/2 theta r squared. You know that formula. If you forgot it, you can just read the formula sheets. And that's why we said over here for the sector area, COD, for the slice, it was just 1/2 times this angle over here, 1/5 pi, times the radius squared. See why we use that relationship over here? See how that works? See how that helps to solve this question, is my point. That's why we care. Why do we care about these formulas? Look at this. If we want to find the... Because we know for a fact we can't find the shaded area if we don't find this shaded area first, don't we? The sector area from ABC. How do we find the sector area of ABC? It's going to be 1/2 times 5 squared times this angle over here for ABC. Which is what we've done over here. 1/2 times 5 squared, 1/2 r squared times this angle over here. This angle came from... The reason why it's going to be pi minus 1/2 pi minus 1/5 pi is, well, pi represents 180 degrees, doesn't it? 180 degrees minus this angle over here, which is 1/2 pi, because 1/2 pi is just 90 degrees, minus 1/5 pi. See how that works? That's the angle that represents ABC. 1/2 times this angle times radius squared gives us this sector area. So do you see how we use those formulas? Use the knowledge of those formulas, when to use them, yeah? To be able to solve larger questions.